A probe sent to Jupiter has contaminated one of its moons with Earth life. An extremely durable bacteria known as Deinococcus Radiodurans somehow slipped past NASA's sterilization procedure and has hitched a ride to Jupiter. The probe landed on the fifth largest of the Juno moons, Amalthea. This bacteria is extremely radiation resistant, able to withstand up to 500,000 rads. For context, a human can only withstand 500 rads. It can also withstand long durations without water and can survive in vacuum. Life from Earth has finally reached the outer solar system. It just isn't human life. The moon Amalthea is now the second body in the solar system to harbor life. The bacteria has taken root on the barren surface and will begin to adapt to the local environment. Clearly a resourceful and adaptive species, Deinococcus Radiodurans is a true extremophile, often forming tetrads, groups of 4 bacteria, seen here, aid in its ability to self-repair. The bacterium is able to repair its genome nearly from scratch repeatedly, albeit with frequent mutations, aiding in quicker evolution. This ability alone equips Deinococcus Radiodurans as the perfect candidate for panspermia. Bacteria blown to ice pockets were the first to truly begin surviving on Amalthea. The first adaptation taken by life on another world was simply thicker cell walls. Already able to withstand years of dehydration, the thickening of its cell walls helped retain moisture longer, enabling it to hold out until conditions were right for it to survive. Conditions on Amalthea are extreme, even for Deinococcus Radiodurans. To cope with harsher conditions, the bacteria began forming larger groups, adding a 5th and 6th member to its already impressive arsenal of gene-repairing defenses. Over time, the 6 separate bacteria would distribute resources intended for their individual cell walls to the outer cell walls of the bacterial group, aiding in resilience and further moisture retention, as well as increasing reliance on each of the 6 bacteria. The outer walls of the bacterial group had grown even stronger. Such adaptations reduced damage from radiation and allowed for individual bacteria of the sextet to begin specializing, acting more like organelles of a larger cell. The most successful lineage, the one that would be the sole organism from which all further void life would emerge, had an organelle begin specializing in photon capture and conversion to energy, and in turn, another organelle adapt to retain the energy as heat, growing larger. 2 others kept their ability to self-repair, a vital skill in this environment, and the final 2, found in the middle, acted as a sort of sponge for the organism. The bottom organelle processed toxins, while the top held excess nutrients for the cell in times of stress. The first truly alien life form had emerged. This new organism was successful in the harsh environment, found in isolated pockets of water ice, having to dehydrate for long periods of time and pouring the vast majority of their resources into reproduction. The largest organelle, adapted to photon capture, which we will call photoid, began to fold as a result of mutation, allowing excess energy to be captured by the cell. This in turn caused the organelle responsible for heat retention, which we will call thermoid, to fold in an effort to keep up with the increased energy. Alongside these changes came large changes in the middle organelles. The organelle responsible for filtering toxins, known as Toxicus filtrum, began to elongate. There is no shortage of toxic chemicals in this environment. The top organelle, known as alimentum, responsible for storing nutrients, grows larger as well as longer, connecting directly to each organelle within the walls of the organism. The alimentum would be essential in the next step for our void life, penetrating the cell wall and allowing for collaboration amongst neighboring organisms. As the first bit of life takes hold on this barren moon and begins to spread and adapt to other niches, what forms will such life take? How will it obtain energy? How will it reproduce? What incredible creatures will arise as life from Amalthea spreads into Jupiter's Gossamer Ring, its other moons, and eventually the atmosphere of the gas giant itself? Thanks for tuning into Weird Universe. If this is something you find interesting, and you'd like to see more of my speculative evolution project following life adapting to the environment of space, please leave a like and a comment. Be sure to subscribe and check out some of my other videos as well. If life such as Deinococcus Radiodurans got a foothold in space, what do you think would happen? Would it adapt and survive? Or would space be too much for it? Let me know down in the comments.